Hello everyone. We want to continue with another example on synthetic division and how we apply that in curve sketching of polynomial functions. So if f of x is this cubic function and it has one factor of 2x plus 3, determine its zeros first of all. So we have to find the zeros of the function or the x-intercepts of the graph, and then sketch the polynomial function's graph. That's what they're asking us to do. So we're going to say, okay, so this cubic function has one factor, which is 2x plus 3, and we can divide the function by 2x plus 3, and find the quotient. And this way, we know, of course, the remainder is 0, because clearly 2x plus 3 is a factor of the f of x. So we're expecting a 0 remainder actually, but this way we'll be able to factor f of x basically. So let's see how this can be done. So we have 6x cubed plus 5x squared minus 15, and this is equal to 2x plus 5 plus some other expression, some other quadratic expression, okay, g of x. I can in fact write a quadratic expression here, ax squared plus bx plus c, because it's not a secret that when you multiply a quadratic expression by a linear expression, you end up with a cubic expression. So the thing is that we don't know what that is. So in order to find that, we are going to divide. We're going to divide the cubic polynomial by 2x plus 3, but we don't want to use the long division because it's long, so we want to use the shortcut, the fast method of synthetic division. So I go 6, 5, negative 16, negative 15, and here, as I said last time, we have to write the root of the divisor. What is the divisor? Divisor is 2x plus 3. How do you find its root? Set it equal to 0. So if you solve for x, okay, you get negative 3 over 2. So always here, we write the root of the divisor. So I should write here negative 3 over 2. Okay. And now I start the process of synthetic division very fast. So I bring this down. 6 times that would be negative 9. Add them up. Negative 4 times that would be positive 6. Add them up. Negative 10 times that would be 15. Add them up. 0, as it was expected. We expected to get a 0 remainder because we did know, it was given, that 2x plus 3 is actually a factor of the cubic polynomial. So whatever the quotient is, times the divisor plus 0, which is the remainder, would be the dividend if you write the division statement. So now we end up with the quotient as 6x squared minus 4x minus 10. Now the puzzle is solved. So this ax squared plus bx plus c, which I didn't know what it was before, but I knew that it's going to be quadratic. Now the puzzle is solved. We know exactly what a, b, c are. Okay, so now I can say, if I call this f of x, I can now say that f of x is 6x squared minus 4x minus 10, which is the quotient, but then times here, times x minus k. You always said that in synthetic division, we can only divide by x minus k. So here, I should write x minus, minus will be plus, x plus 3 over 2. So this product is what is equal to f of x, basically. So if you write 2x plus 3, it will be wrong. Now, on the other hand, you're scratching your head. You're saying, well, we had 2x plus 3 times that quadratic. Well, you're right. It was, and we will shortly get the same thing. But this quadratic expression is not 100% the same as that quadratic. What I want to say is that ABC values are not 6, negative 4, negative 10 exactly. Okay? See what happens here. If I factor 2 out, okay, so I'm going to get 2 and then 3x squared minus 2x minus 5, all right? And the second binomial remains unchanged. And now these two can be multiplied by the second binomial. So I can multiply it by this, I can multiply by that to get rid of the fraction. So I will end up with 2x plus 3 if I multiply 2 by the second binomial. And then the first one remains unchanged. And now you see that this is a perfect match with what we had before. So 2x plus 3, 2x plus 3 times the quadratic times the quadratic. So now I can say ABC values are actually 3, negative 2, negative 5. Okay? So f of x, which is the dividend, okay, the original cubic function, finally is equal to 2x plus 3 times 3x squared minus 2x minus 5. All right? Now, can this quadratic trinomial itself be factored? Well, if yes, you must factor it. If not, you leave it as it is. It's not your fault. We didn't say that every single quadratic trinomial in the world is factorable. We never said that. But if it is, you must factor it. So we're going to try to see if we can factor. So how would you factor this? I would say perhaps we have 3x and x. I'm just using the guess and check method. So 3x times x. Okay, and then here we might have 5 and 1. So let's see. If I go 3x squared, this is 15, it's not going to work. But if I put the 5 here, okay, and the 1 there, it may work. So this is like the trial and error method, although there's all sorts of techniques of factoring that can be used, including decomposition method. So 3x squared, it works if I'm doing the foil in my mind. So that's 3x, and this is 5x. So I would go negative and positive. So now it works perfectly. 3x squared, 3x minus 5x is negative 2x, and negative 5 times 1 is negative 5. So we factored f of x. So that cubic function is now factored, and this is a big deal, right? Because we can use this big deal basically to draw the sketch of this polynomial. What are the zeros? Well, I would say if you set f of x equal to 0, you're going to get either 3x minus 5, 0, or you get x plus 1 equals 0, or 2x plus 3 equals 0. So that means that x is 5 over 3, or negative 1, or negative 3 over 2. So the question says find the zeros, and we did find the zeros. These are the 3 zeros. How do you sketch these? Well, this is negative 1.5 right here. That's negative 3 over 2. Negative 1 is right beside it, I guess. And this one is 5 over 3, which is about 2.7. So, no, not even 1.7. So that's 5 over 3 right there. So we have 3 x-intercepts for the graph of this cubic function, or 3 zeros for the function. The leading coefficient happens to be 6, which is positive. So leading coefficient is greater than 0. Degree is odd, it's 3. So we know that the graph has to extend from quadrant number 3 to quadrant number 1. It is falling on the left and rising on the right. So it's going to have some sort of behavior like this, some sort of behavior like that. That's the end behavior. Okay. So because all these factors have an order of 1, the exponents are 1, so simple crossings are happening at the x-intercepts. We have extensively discussed all of this in the past. So simple crossing at negative 3 over 2, and then we have turning point, simple crossing at negative 1, and then it goes down. The y-intercept is negative 15 if you set x equal to 0. So negative 15 is right here. So it's going to go down all the way. It's going to cross the y-intercept of negative 15 to be as accurate as possible. It's going to go further down, okay, and then we have another turning point because there's another 0 waiting for the graph to pass through it. So it's going to go up and crosses the x-intercept of 5 over 3, and we have 2 turning points, and this becomes a sketch of this cubic function. All right. we have labeled the x-intercepts. It has 3 x-intercepts. The y-intercept is -15. We have 2 turning points, and this is just a sketch of this polynomial function. Okay, so please review this procedure of how we factored the given cubic equation, knowing one of its factors, and also remember what we did here in terms of factoring out 2 and then multiplying it by the other binomial so that it would perfectly match with what we have on the right side of the equation of f of x. Okay, thank you for your attention and keep practicing.